Hi, my name is Saeedloo, and I will be presenting a research on the effect of T-consciousness fields on heavy metal uptakes by Saccharomyces cerevisiae under altered gravity conditions. Saccharomyces cerevisiae, a key organism for studying cell functions and environmental cleanup, effectively captures heavy metals using its cell wall component. These metals are classified based on their biological significance and harmful impacts, which are intensified by industrial emissions, presenting substantial risks to both the environment and human health. The focus of this investigation is to T consciousness is considered the core element of the universe, which can be studied through experimental approaches. These experiments are specifically designed to evaluate the effects of TCFs. In this study, a two-dimensional clinostat was utilized to simulate a near weightlessness environment, enabling the examination of whether the TCFs influence the bioabsorption and how that varies with gravitation. Heavy metals pose significant ecological and health threats. The Industrial Revolution has exponentially increased their presence, urging the development of innovative removal methods. This study is motivated by the need to explore the potential of TCFs in improving bioabsorption process by Saccharomyces cerevisiae in both microgravity and Earth gravity conditions. We started by applying three variations of TCFs to Saccharomyces cerevisiae. This controlled experiment was conducted double-blind and followed Cosmo-Intel guidelines to ensure unbiased results. The yeast cultures were divided into four groups. Two were subjected to a simulated microgravity environment, and two were maintained under normal Earth gravity. Within each of these environments, one group was exposed to TCFs and the other was not, allowing us to assess the effect of TCFs on bioabsorption under different gravitational conditions. In cultivating the yeast Saccharomyces cerevisiae ATCC 9763 was grown under aerobic conditions until it reached the exponential phase, which is suitable for bioabsorption experiments. This ensures that our observations are reflective of the yeast's peak bioabsorption activity. For the biomass quantification, we used a serial dilution method to accurately count yeast colonies. This step is crucial for determining the starting density of our cultures before testing bioabsorption capabilities. Lastly, in next steps, we prepared glass containers and tools carefully to prevent any metal contamination, which is crucial for a clean study of how yeast cells absorb heavy metals. Following this setup, we exposed the yeast to these metal solutions to start the bioabsorption process. For simulating microgravity, a clinostat was used to create conditions similar to those in space, giving us insight into how weightlessness might affect the yeast's ability to bind with heavy metals. We treated samples with TCFs in both the microgravity and start-on gravity settings, while also keeping untreated controls for comparison. Clinostat device simulated microgravity at 15 rpm. The rotation was for 24 hours. In this section, we present our findings on the effect of T-consciousness fields on the absorption of 4 different heavy metals by Saccharomyces cerevisiae. At this stage, we analyze the residual concentrations of arsenic, cadmium, lead, and mercury in various samples. We then observe the changes in the concentrations of heavy metals under microgravity and Earth's gravity conditions. According to the obtained data, yeast's potential for heavy metal absorption is observed in the first instance. The highest absorption was related to mercury, and no significant changes was observed for arsenic. Microgravity conditions significantly increased the absorption of lead and mercury, but had no effect on arsenic absorption. This suggests that gravitational conditions may influence the natural ability of yeasts to absorb metals. These results provide a quantitative perspective on the potential impact of T-consciousness fields on bioabsorption process in different gravitational environment. In this section, we observed the results of ANOVA tests that evaluated the effect of T-consciousness fields on the absorption of heavy metals by yeast cells. Bar charts compare the residual concentrations of arsenic, cadmium, lead, and mercury in our yeast cells under 2 conditions of microgravity and Earth's gravity. The statistically significant changes in our findings are indicated by 1 stars represent a p-value of less than 0.05 and 4 stars indicating a p-value of less than 0.0001. These results demonstrate the impact of T-consciousness fields on the bioabsorption process. For instance, under microgravity conditions, the T-consciousness fields caused a significant reduction in the concentration of arsenic. On this slide, we see the box plots of the effect of TCFs on residual heavy metal concentration within Saccharomyces cerevisiae. The box plots show the range and median value for arsenic, cadmium, lead, and mercury under both microgravity and Earth's gravity conditions. We compared these findings against the standard levels to determine the effectiveness of TCFs in altering metal uptake. For example, under TCF influence in microgravity, lead and mercury levels show a significant decrease, marked by 3 and 4 asterisks, indicating a highly significant reduction. In our findings, we note that while microgravity affected Saccharomyces cerevisiae bioabsorption of metals, with a significant increase in the removal of lead and mercury, arsenic uptake remained constant. However, under TCFs, as removal rose markedly in microgravity, in Earth's gravity, TCFs unexpectedly reduced the bioabsorption of some metals. These diverse responses underscored. According to Tahiri, samples exposed to TCFs received information. Here you can see our research team, and thank you for your attention. For more articles and information on the research of these fields, please visit Cosmo Intel website. We would like to invite laboratories and research institutions for collaboration on further investigation of TCFs in various fields. Thank you for your attention.